Well, we're entering the decisive decade for solar deployment in Europe, where PV moves from being an upstart to becoming one of the central pillars of our new energy economy. Hello and welcome to this PV Magazine Roundtables Europe event. My name is Jonathan Gifford and I'm the editor-in-chief at PV Magazine Global.
And I'm Frédéric Dross, head of events at PV Magazine. Over the next 2 days, you can expect a tightly packed program with over 50 speakers from all around the world on this very beautiful stage. Our agenda centers on 4 cornerstones that define our industry. Today, we will focus on 2 cornerstone sessions, quality and asset management. Tomorrow, we'll look at the pros, cons, and opportunities offered by sustainability and Made in Europe PV. We also look at hydrogen and battery storage in our Cornerstone Sessions Innovation Hub. But these roundtables offer you more than just this live stream. In our event space, you can network with over 2,500 registrants. If you're not keen to network one-on-one via attendee profiles or join the English networking sessions, check out our German, French, or Spanish networking rooms. I know our regional editors are looking forward to meeting you there. During the lunch break, you can also participate in speed networking or continue to solve challenges and compete for the top 3 in our Play to Win scavenger hunt. We have great prizes on offer, including a 1-hour virtual meeting with PV Magazine's own publisher, Eckert Gors. Our colleagues are also covering this event live on our websites, from global to Germany, from France to Spain. They're also sharing their experiences on social media, so join them and be part of the discussion there and use the dedicated hashtag RTEU21.
And of course, none of this would be possible without the support of our networking partner FEMA and our platinum partners DuPont, Goodwe, Growatt, Jinko Solar, and Smart Energy, and our gold and silver partners also. As Frederica mentioned, there are lots of ways you can get involved over the next 2 days, and that includes right here on the main stage. And that's by submitting your questions to our speakers and panelists. On the event app, directly next to the live stream, you can shoot through your questions or comments. And you can even upvote other people's questions when it's something you'd like to see addressed. So please do get involved. We'd love to hear from you. I think there's a pretty good chance that you've been involved in one of the Quality Roundtable events in the past, and there are some familiar faces in the program today. Since 2015, PV Magazine has been hosting Quality Roundtables, and we've taken the event to 5 continents. And a part of these discussions has always been our quality case studies. These are real-world examples where quality has fallen short, and we discuss what may have gone wrong and how, as an industry, we can avoid such mistakes from occurring again in the future. Coming up shortly, we'll be discussing a case from Germany, where we can see that even a tiny detail has resulted in troubling and ongoing maintenance issues.
Before that, though, the emergence of large format and high-powered modules is the biggest technology trend in the European marketplace in 2021. And as is the case with any new technology, apart from opportunities, it also brings risks to be managed. So let's hear from 4 independent quality assurance providers and hear what they are seeing in the market with these new module formats. Jonathan, I'll let you introduce our pitches and join you again for the panel.
Thanks, Frederica. As there are a number of different aspects when it comes to product and also project quality relating to large format modules, we've got 4 different perspectives today. Our first quality pitch on these new large module formats comes from Synergy Technical Services, perhaps best known simply as STS. Founded in 2010 and with a presence in 9 countries across North America, Europe, and Asia, STS currently has contracts to provide quality assurance services for more than 40 gigawatts a year, including 20 gigawatts of module production supervision and 10 gigawatt hours of battery energy storage systems. Frédéric Dross serves as the VP of Strategic Development for STS. Frédéric, welcome to the Quality Cornerstone at Roundtables Europe 2021.
Thank you, Jonathan.
And please, take us through. What are some of the quality issues that you've been encountering at STS in terms of these large format modules?
So, yeah, thank you for that. I am guessing that you are seeing my screen and you are seeing my slides as well. So we have prepared a couple of slides. Yeah, okay, that's popping up right now. So we have compiled a couple of slides just to illustrate the type of quality assurance that we see. Even more than large module technologies, I want actually to talk about the synergies between multi-wires technologies and large modules. There is definitely some synergies between these two technologies, and that comes from the fact that large modules is typically made from larger cells, which means larger currents, which unfortunately means, if you don't pay attention, larger series resistant losses. And you see that when you start looking at the details and you realize that the current which is flowing through one of these bus bars is equal to the current density, which is represented by J here, multiplied by the area that this bus bar is covering. And then the loss of power, which is resulting from series resistance in each of these bus bar, is given by the simple ohm loss rule. You multiply the series resistance multiplied by the current to the square. That gives you the loss. So you see that the current is at the square. So it means that if you increase the area of that is covered by one bus bar, you will actually increase the current. So there are a couple of strategies to reduce the series resistance losses. One of them is to cut the cells, the larger cells, into smaller pieces, and we've seen that as a trend in the last few years. And the other one is to introduce more bus bars. So we do see that multi-wires are very synergetic to large modules. However, what we also see challenges resulting from this trend, and I want to highlight three of them very briefly. So the first one is increased risk of performance issues. The second one is risk of soldering issues, and the last one is risk of cracks or micro cracks. So regarding performance issues, I want to point out to the fact that reducing the series resistance is extremely efficient for increasing the performance at high irradiance. So you see, if you plot, and that's just a design plot, the efficiency as a function of irradiance, you see that with a high series resistance module, you will get maybe something somewhere here. And if you lower the series resistance, the effect will be mostly visible. Again, power loss equals R times I square. So if you're reducing this series resistance, it will have a higher effect with a high photocurrent, and therefore with a high between these two. If you don't change anything, just the series resistance will be mostly at 1 sun. Now what happens if you, so that's in absolute value. But the problem is that the rating, typically low irradiance performance, is given in relative performance. So what you do, you just scale these down, this orange curve. You just you make it fit to the performance at high irradiance, and then what you see is that by just scaling this down, you end up having relatively a lower irradiance, a lower efficiency at low irradiance for the actually low series resistance module. And that is important because the performance at low irradiance usually happens during the day at moments where there is no clipping of the inverter, for instance. So you do start losing some power and some energy in your system. Root cause is that the low irradiance is scaled to 1 sun performance, that the BOM may be not controlled during the pan file generation, and maybe that the nameplate performance is only reported at 1 sun. Possible effect is loss of energy during the operations, and then mitigation. We do recommend including the pan file parameters into the purchase agreement. We do recommend witnessing the BOM during the pan file selection, the sample selection for the pan file, and we do recommend measuring the low irradiance performance for every lot or every batch. So that's one risk that we see. Another risk that we see is desoldering. So this sometimes more complex interconnection scheme may lead to some soldering issues. What what are the root cause of that? Maybe the FMEE was not perfectly done during the development. You also have usually, with these small wires, a smaller contact or soldering area. The stringing process may not be fully under control, or we've seen also insufficient control on the line. EL calibration, visual inspection, operator training is a big one. And yeah, overall, it may just be a more difficult technology to make work, and that's just illustrating that. If you look at the rework rate for one particular module manufacturer, and different months of production of 5 bus bars, so ribbons, and 9 bus bar wires, you see that the rework rate is actually higher about 30% higher for the 9 bus bar wire. So possible effect, you may lose power, you may have hotspots. How do you control? How do you mitigate for that? We recommend very careful electroluminescence control. We do recommend 24/7 inspection. 80% of our customers are doing that, 24/7 inspection, and we do recommend also a very robust QCP quality control plan. And for that, we have actually developed a standard that we published in 2018, and again, 80% of our customers are using this standard in their approach. One other thing that can help is doing some testing, some standard testing, and we have this 63209 ICTS 63209 that was published in April this year, that can be useful for that. And last but not least, the speaker right after me will talk about that, I'm sure. The micro cracks and crack risk, which are increased for multi-wires. So if you plot the regular bus bar and a multi-wire at scale, so this is at scale, so you see the blue here is the wafer, and a couple of years ago it was more in the order of 180 micrometer. Now it's very common to see 160 micrometer in wafer dimensions, and then you see that the wire is twice as thick as the cell itself. So when plotted like that, it's quite striking that this is a big piece of metal on top of the fragile wafer. That's the first thing you see, and you also see that the area of contact, and therefore the area of pressure, is also much reduced compared to the bus bars. So what it means is that, well, you do have a higher pressure at this point, and higher pressure means that you are more likely to reach the toughness of the material and potentially create micro cracks. So we do see that, and for instance, one example here, where you see some very tiny start of a crack that may turn into cracks during either transport or handling or just normal operation, thermocycling. And what we see is that the crack very often originates at the edge of a wire, at the intersect between the wafer and the wire. That is sometimes worsened by the fact that the cells are cut, and therefore the laser cut cells may introduce some irregularities also at the edge of the wafer. So again, what you recommend is careful EL control, the EL calibration, the resolution of the EL images, all that is extremely important. The training of the operator as well, to detect these tiny cracks that can be very small. So you really have to keep an eye on that. 24/7 inspection. We see twice as many findings during the night shift compared to the day shift. So 24/7 is very important. Robust QCP as well. Our standard takes into account the new issues due to laser cut cells and to multi-wires, multi-bus bars. Testing may help as well. And we understand that some of the manufacturers are aware of this issue, and they are right now designing what they call segmented ribbons, where you have some flats in between some segments which are flat to go from one cell to another, and some segments which are not flat, either triangular or wires to go on top of the cells. And that's it. That's what I wanted to share with you today.
Thank you very much for that, Frédéric. Frédéric Dross is the VP Strategic Development for STS. Now, Frédéric, while I have you, we have one question from our audience. Is the desoldering risk that you were talking about, does that also apply with these new cell interconnection methods and also cell layouts that you did mention, things like paving and tiling? Does this desoldering risk apply to paving and tiling?
Desoldering risk, does that apply to paving and tiling? So paving and tiling, the risks are different. They are not as such desoldering. There are other risks. You typically use some conductive adhesives, and actually we have also taken this new risk into account in another addendum to our standard for manufacturing control. So these are different risks, I would say.
Okay, excellent. Well, Frédéric, thank you very much for your time. Please do stick around. You'll be joining one of our panel discussions later. Frédéric Dross from STS. Well, up next for our quality pitches comes from Taiwan, from PV Guider. PV Guider has provided quality assurance services for projects with a capacity of more than 50 gigawatts and in fact is celebrating its 10-year anniversary in October of this year. PV Guider's chief consultant holds a PhD in engineering science, began working as a researcher at Taiwan's ITRI in 2004, and is a qualified auditor of the Taiwan Accreditation Foundation. Jay Lin, welcome to Roundtables Europe.
Hi, Jonathan.
Great to see you, Jay. Well, you're going to take us into, as Frédéric said, a little bit more deeply into the risks of cell cracking with these large format modules. So I'll hand the stage over to you.
Yes, yeah, thank you. So can you see my slide now?
It will just come up in a moment, Jay.
Okay.
There we are.
Okay. So it's my pleasure to share our experience in module quality control. So today I will share with you about cracks in high power module, especially for half-cut cells. Okay. I find the slide is moving slower than mine. So okay, I will continue my presentation. For the cracks, yeah, this image is provided by the module manufacturer during our pre-shipment inspection. And for the inspection, we always need to check the quality of all these images. And we found this image as a big issue is that the quality is very bad. So the slide moves slower than I expected. So in the image, you will see the resolution is very low and the camera is not well tuned in the right focus. And the image is blurred, so you cannot see all the details. So we asked the supplier to improve the image quality, but they said that it's the best they can do because it's the limit of the equipment. But actually, we know the equipment very well, so we help them to adjust the machine. Later, we get a better quality, and you will see the image is much more clear, and there is a crack, which is obviously there, but in the previous image, you cannot see it. And what's more important is that we can see all the details in the EL image, and including the small cracks. These small cracks, they are generated during the process. But if with the previous EL image, you cannot see anything. But with the improved EL quality, you can see these small cracks. So I would say the first lesson is that EL image quality is very important. It will help you to see all the details. And next question is that what about these small cracks? Do they really cause some serious issues because they are so tiny? So in the next slide, I show you the example from another factory, also in pre-shipment inspection. We found the serious crack in the cells, and of course the module is rejected. But we also checked the EL image took in the production, and we found the small crack was already there in the production, but only after internal transportation the cracks grows to very big and have serious effect. What about the cracks in the field? In the field, we also do some EL inspections, and very often we also see this kind of small cracks. And these cracks, if you put it on the mechanical load, you will see the cracks propagate a lot, and some of them even form a serious inactive area. And I have to say, the impact depends on the design of the cells. For example, for multi-bus bar cells, the impact is much smaller, but for 5 bus bar, 4 bus bars, or fewer bus bars, this can be a very serious problem. So as a summary, I would like to say, first, new technologies always come with new problems. So it's very important to have some stress tests to check if there is any unexpected defect. And the second point is that EL image is very important. And as I have shown, in poor EL image quality, you can almost see nothing. And the last but not the least, defect modules, sometimes they are delivered unintentionally because the module manufacturers, they don't know, they don't see the defect because of the equipment limit, or they see it, but they don't know it is a problem. And for that, I would suggest you to have a third-party quality control that will help you to notice all these issues. And also, if you do some sampling EL on site, that would be very helpful to control the quality of your plant. So that's all of my presentation, and I'll give it back to Jonathan.
Thank you very much for that, Jay Lin, the Chief Consultant with PV Guider. Jay, we have a question from our audience. If cracks appear during operation of a plant, which quality control measure would you recommend to determine responsibility? How can you determine where the cracks appeared? Did they come from manufacturing, transport, or installation? What do you suggest there, Jay?
Yeah, regarding the responsibility, it's if you only take EL at the end after installation, it's difficult to judge the responsibility. So our recommendation is that at every stage you have the EL inspection. For example, before shipment and after shipment, when the module arrives, and before installation, you do some sampling check. And after installation, you have another sampling check. Then you have the EO image at each stage, and it's more easier to judge who is responsible for the cracks.
Okay, multiple testing. Jay, thank you very much for your time from Taipei today. We look forward to celebrating your 10th anniversary with you later in the year. Thanks for sharing your learnings about these large format modules and cell cracking. Well, moving forward with our quality pitches, our third pitch comes courtesy of Clean Energy Associates. With headquarters in both Denver and Shanghai, CEA has worked on more than $70 billion worth of projects since its founding in 2008. From CEA today is the company's Director of Technology and Quality in Solar and Storage. He has 11 years experience in both project development and manufacturing and currently leads projects on internal quality standards, new production technologies and new services. From Clean Energy Associates, George Touloupas, it's my pleasure to see you again as part of one of our quality events here at PV Magazine.
Thanks, Jonathan. Very nice to meet you.
Nice
to
see you again. Thanks for joining from Athens. Please take us through another aspect of quality when it comes to these large format modules, and I understand related more to the BOM, the Bill of Materials.
Yeah, absolutely. And what the previous speakers presented is very familiar to our day-to-day experience in the factories, but also in the field, because we also do EL inspections. So what Jay showed, there was a very recent case we had in Europe with the V-shaped cracks. And you can actually see the V-shaped cracks right here in the image on the right-hand side. And of course, cold soldering and wire ribbon misalignment and a host of other issues. So we are currently in the process of auditing all new production lines, and most importantly, let's say production lines for new designs. We have paving, we have tiling, and of course shingling, which is less popular, and all this bundled with bigger wafers and cut cells, etc. We also have very thin glass. So it's a host of new technologies, let's say, that haven't been tried. Everything gets optimized, absolutely, to have a higher yield and lower cost. One example is the glass. So tempering very thin glass, 2 millimeter glass, is not feasible, at least with mainstream production processes. So it's heat strengthened or half tempered, which is exactly the way it sounds. It's half the strength, well, roughly half. It's reduced strength. So its impact, ability to bear impact from hailstone is reduced. We have a big problem in the US. It's very well known. There is a lot going on now. It's not mature yet. Everybody realizes the IEC standard is not great. But we also have hail in Europe, as you can see in the map here. So overall, the new bombs and processes are creating a lot of new risks. Now, another view of the changes. So basically now have the two new wafer size formats, the M10 and G12, or 182 and 210, and gigantic plans for multi 10 of gigawatt capacities rolling out now and next year. All this is brand new lines, brand new processes, well, different processes and new bombs. What you see on the right is a chart of maturity for each technology field. So we have devised a system to rank from 0 to 10 according to the R&D maturity capacity scaling up. So after reaching 5 gigawatt, you get a 10. And then shipment, after you reach 5 gigawatt, you get another 10. So maximum score is 30. So you can see jumping from Q4 2019 to 2020, yeah, from the blue to the orange, huge change. Everybody's jumping to the new technologies. These are anonymized suppliers, but you know, all the big names are in here. So that's another very, like say, bird's eye view of the very fast and sweeping pace of changes. There's a bit of lag. There you go. Now, this is reflected on the factory floor, as we've seen from previous presenters. EL defects. Basically, let me explain what you see here. So there are several defect categories. This is based on the pre-shipment inspection. That's what PSI stands for, which is the last step. So inspecting a sample of modules. Of course, you have to do a lot more than that, but this is a very good statistical view of the quality of the products. Of course, when the defects get too high, you reject the shipment. But this is what can be seen on the factory floor from 2018 to 2020. Overall, there is stability. There are some improvements. So the cell quality that's fed in is better. So these are visible cell defects, not EL defects. But the EL defects themselves have risen. And this is mainly due to soldering, cold soldering or weak soldering. Introduction of multi-busbars plays a big role, half cut also, and cracks. And this is very important. So what you see here is not really actually defect rate, it's a risk score. So the defect rate themselves has not increased so much, but the risk of the defects has increased. So more severe cracks. Of course, yeah, before a few years, we had one standard wave size, full cells, 72 cells, big gaps between the cells, and this has changed dramatically. And that's exactly what you see here. Now, what do? We do everything we saw before, okay? As Jay said, for responsibility, you need to do from the factory gate down to pre-installation and post-installation so that you can have the chain of custody of the quality and accountability. It's very important. But this is like a very schematic map, high-level map of CA's approach that, as I said, includes everything that was recommended before, but at a more high level. So the first step is to check the product. We have a set of technical requirements, which is called the golden standard. It checks the product qualification, but also the production and QA requirements. The areas that are marked in red are especially pertinent for the new generation module. So reliability testing, and thank God we have the new IC standard, the 63209-1, that is codifying all these thresher and PQP, etc. standards. So this is a good tool. Of course, IQC, IPQC, all the QA requirements are very critical. And then the BOM review, which is basically a review of the documentation, reliability test reports. We receive and review several sets of reliability test reports on a daily basis. When I say reliability testing, I mean testing that lasts for several months. And of course, a factory audit is very important because we have brand new facilities and brand new processes. And it's very important to do that before going to production. And then inline production monitoring is basically a mini factory audit on a daily or even nightly basis, where we're checking the material, for example, AVA, okay, it's the same type. Is it the same thickness? Because thickness is very important. And pre-shipment inspection, as we discussed, that's where you can really block bad shipments and reject them and have them work. Batch testing is always important. For hail, we see more pronounced interest because the glass can have variability, the glass tempering process. So there is some concern here. Also DML sequence or SML, not so frequently. Definitely LID, LETID, PID, they are there. But these are like cell level, not module level technology. So that's that's a high-level methodology of de-risking the project, especially in this era of cost of new PV module technologies.
Great. George Touloupas, Director of Technology with CEA. Thank you very much for that, for those insights. One question from our audience. What's the simplest method? Well, we've heard about the importance of EL testing, both from Jay, from Frédéric and yourself, but what's the simplest method for EL inspection on site? So when you're actually on the field?
So yeah, we do a lot of that. The simplest is to do nighttime EL inspection. You can also do it during day, but you need very expensive equipment to do that. So we have done the probably biggest project, over 50 megawatt of 90% EL inspection a couple of years ago. So we have a pretty big track record. We have our own equipment. I think this is very effective. So you can do it on a sampling basis and have a very good statistical overview of the status. But of course, you start with the lower bar. So IR inspection, thermography is very effective, very low cost. So that's the first thing that should be done. And of course, monitoring and IV tracing. EL is more like focused, expensive, let's say magnetic resonance. Yeah, first you do the X-ray and then you go to the most expensive diagnostics. But it's very effective. You can really see where it's going. And even if you monitor, for example, monitor cracks, you see how they develop.
Yeah, okay. So you can actually scale it up if things...
Yeah.
If things become a problem over time. George Touloupas, thank you very much for joining us today at Roundtables Europe. Now, we do have a packed schedule, so we'll keep moving forward. We'll be bringing together a panel to discuss these issues very shortly, but before that, let's turn our attention to the power measurement of large format modules. Based in the Netherlands, Eternal Sun Spire provides a range of sun simulation and PV output equipment, including simulators with integrated climate chambers. Alongside this, it also operates downstream testing services at import locations. From Eternal Sun, I'm pleased to welcome a young technologist who was crazy enough to found a Sun Simulator University spin-off in 2010 and has served as the CTO ever since. Stefan Roest, thank you very much for joining us today.
Hi, Jonathan. Good morning. Good to see you again. Thank you.
Absolutely. Well, take us through some of the measurement challenges that these large format modules can present.
Exactly. Hello, everyone. Thank you for joining today. A short pitch on the impact of high power modules, large modules on testing and quality control. Because they are here, they're real. We see them in our import testing facilities, for example, here in the Port of Rotterdam, where we have an import test lab. We are Dutch guys, tall guys. So this module here you see is really big. And a short recap of what you need in general to measure high efficiency technologies, regardless of the size. First of all, you always need that wider spectrum, 300 to 1200 nanometers. So the UV and the near infrared need to be in, because that is where high efficiency modules get their extra efficiency, in the UV and the infrared. Then you need a good uniformity, of course. So the right intensity all across the surface of the module. And also important nowadays with smaller cells is that the resolution of the uniformity, the size of the detector, needs to match the size of the cells in your module to have the right uniformity for the right cell size in the module. Last part is, of course, a good spectrum, a long pulse, for example, to avoid those capacitance effects or get a small error from that. So that's for high efficiency in general. Then large modules. Any light source, any flasher will always have the intensity dropping at the edges. And that goes really rapidly. So from the edges, like here in this picture, if you put a 2.4 meter module in a 2.1 meter flasher, for example, the intensity rapidly drops 5, 10, 20%, leading to a class B or C uniformity on these kind of sizes if you don't upgrade the size of the flasher. You can, of course, put more energy in the same light bulb to get a bigger plane, but then you have the big risk that you reduce the pulse width, first of all, because you need more energy, and the lamp life, because you're burning your lamp stronger, basically. So that is the challenge. And what we did on our tabletop flashers, we scaled the lamp and the optical components in the length of the machine to keep the same performance in a larger size. So the same full spectrum, the same good uniformity, the same long pulse, but with the same lamp life as well. And this is it. It's here. It's running already in many factories and laboratories around the world. So on the right side, you see the 2.1 by 1.3 meter flasher. And on the left, the scaled up machine 2.6 by 1.4. And there in the middle, you see that new longer lamp that enables keeping the same performance on those larger sizes. And the quote on the bottom is from Jörg Althuis at the Taiyang News Conference recently, which I think was spot on.
Thank you very much for that, Stefan.
That was it.
Perfect indeed, and thanks for quoting me as well. Always nice to be quoted at a presentation. And just quickly from my side, are you able to quantify kind of how much inaccuracy could be entered by, if there is this loss of uniformity in the measurement?
Yeah, very, very good question. Well, if your large module reaches the edges of that test surface and intensity drops for example, 10%, then typically, depending a bit on the strings and the bypass diodes, but in the fill factor, you get often a step in your IV curve, and you can have losses in your fill factor of around 2 to 5%, that order of magnitude easily, depending a bit on the exact patterns. But several percents of losses easily, and if you go too far out, of course, that can drop really fast. So that's my main message: be careful with those with your flashers around the edges of the large modules when testing them. Okay,
well, important for buyers to know what they're buying. Stefan Roest, thank you very much. And thanks to all of our quality pitchers today. We'll discuss these issues and the wider market consequences right after this.
And before we get to this panel, I saw a question regarding the presentation and slide decks from our attendees. And I just wanted to let you know, of course, we'll be sharing the slides and presentation decks, which are made available to us on our platform after this session has ended. So don't you worry about that. But now to the panel. To discuss these issues and the dynamics that we just heard about, we welcome 4 experts. First off, Hongbin Fang, as Director of Product Marketing. He has been with Longi Solar since 2016 and will share his expertise from over 20 years in the industry. Secondly, we welcome Cormac Gilligan. As Associate Director Clean Technology and Renewables at IHS Markit, he is responsible for managing the research of the global PV inverter and balance of system market segments. And thirdly, also joining us is Simon Meijer, founder and CEO of the module technology developer Coolback company. He will share insights from more than 10 years' experience in the industry. Last but not least, we welcome Vice President Sales EMEA of Shoals Technologies, Josep Tienda. Josep is joining us from Spain, where he's growing Shoals' presence in key international markets. Welcome, everyone.
Thank you. Hello.
Hi. As our discussion is focusing on our previous quality pitches, Jonathan, can you give us a quick recap?
Yeah, absolutely. And great that those presentations will be available a little bit later. And also to our top tech team, I'm getting a bit of a feed in my ear. I think I'm getting the wrong feed, so if you could quickly swap that out. Well, great that we have such a collection of experts here available on our stage, and we've really heard a range of quality issues that can arise with large format modules. So let's really quickly recap them before we get into the discussion. So modules optimized to reduce the effect of series resistance may exhibit reduced performance at low irradiance. More complex soldering and thin wires requires high precision tabbing and stringing. There can be micro defects from the cell cutting combining with increased thickness of the MBB wires and also the narrow cell gaps. The thicker encapsulant is required, and also to reduce that shear ribbon force, and also not fully tempered 2mm glass is commonly used, particularly in bifacial. And there's a potential reduction in flash uniformity at the module edges. So there's a lot to get through. Let's get straight into our discussion. I also see lots of great questions coming in, so we'll be getting into those during the discussion also. Now, first of all, I think we have a module maker as a part of our panel today. So Hongbin, I'm going to bring you into the discussion straight away. We've heard from the quality assurance providers that there are some concerns regarding these large formats. As a module maker, how would you describe what Longi is doing to kind of meet some of these concerns?
Yeah, this is a great question. Can you hear me okay?
We can indeed, and I apologize, there's a little bit of background noise here.
Okay. Yeah, so basically these are valid concerns, right? The PV systems are built to last more than 25 years with consistent, energy yield and then return on investment. It needs to sustain against extreme weather, conditions that are happening every 50 years or even 100 years, right? So reliability is the foundation and prerequisite to achieve low LCOE that, promoted by all the new product, right? We take the reliability very seriously. All these issues, all the new technology development and then deployment are targeted to, provide better value to our customers. So the module and the system reliability are the insurance to deliver the value to our customers. We think, with the large format modules, and it has helped, in the last couple of years, right? The module size change from, M2 to M6 to M10 has enabled continuous BOS cost savings for our customers. But continue, going forward, the economic benefit, like BOS savings, from further increase on the module size, probably by larger size, increase on the module power by using larger, module size is going to be limited. But at the same time, the reliability risk will be much higher, right? So utilizing larger wafer and module to increase the module power, we think, we want to settle around, 182 millimeter and 72 cells.
Okay, thank you, Hongbin. So there are also measures that can be taken in production to kind of reduce some of these risks. Can you take me through, what is the approach to kind of reduce the risk of cell cracking, for example, is something we've heard a lot about?
Yeah, first, I think we want to make sure, the size won't get any larger, right? So we think this is a 182 millimeter 72 cell, probably as large as you want to go. And any larger than that will make the reliability risk much higher, right? And in terms of reliability risk, there are a couple of, main, concerns. The first one is mainly on the mechanical strength, right? You think about it, the bifacial modules nowadays, most people are using, 2 plus 2 millimeter glass, right? With the same, glass strength, then increase the module size, it's going to increase its vulnerability, right? And under the same pressure, the deformation with a 1.3 meter span is about 40% larger than the 1.1 meter span, modules, which is going to increase with the larger deformation, will increase the micro crack formation risk, and also the glass breakage, on the backside, right? That's going to be, much worse. And the other thing, probably, people probably realize, on the tracker, you only use 4 bolts, right, to connect the module to the rail. And the larger size module experience larger shear force at each contact point under the same pressure, right? And which increases for the frame tearing, risk and due to fatigue. So these are the mechanical strength. I think with a with a 2.2 plus 2 millimeter glass, it can only be that much stronger, right? Much strong, and so it's limited. So increasing the module size, which is increases the reliability risk. So we are totally against going to larger module sizes, right? Simply increase the module size is not an effective way is not a responsible way to help our customers to realize low LCOE, right? So on our hand, what we want to do, we want to constantly, evaluate and then deploy advanced technologies that can help to mitigate the risk and then reduce to improve the module reliability. One of the risks I think that people have highlighted in the last few presentation is the micro crack formation, right? One of the directions we try to help on that regard is to introduce this smart soldering technology, right? Smart soldering basically use a prefabricated segmented bus bar, right? The front side on the front of cell using triangular shape bus bar to improve the light capturing, and then also the thin flat segment between the cell spacing, right, and also on the back side of the cell will enable the small spacing layout to improve the module efficiency. At the same time, can improve the reliability by reducing the ribbon stress. Right, with the deployment of smart soldering, the production yield is improved significantly. The micro crack, is almost it's a micro crack free, right? And we also have tested with the extended reliability, right? With the sequential tests, start from a static mechanical loading, followed by dynamic loading, and followed by TC that showed, smart soldering technology offers, the modules with the smart soldering can demonstrate a fewer micro cracks after this series, extended reliability testing, and then less power loss, is observed compared to, competitions. Which is normally use a round ribbon and then doing the in situ deformation, right, during the soldering process, which have left a lot of residual stress on the string on the ribbon, which going to after the lamination going to introduce more cracks, micro cracks on the cells.
Okay.
Yeah, so these are the
Hongbin,
approaches
Fang,
we're taking.
thank you very much for taking us through some of those. A pretty clear message coming from Longi about what kind of module sizes, and particularly about mechanical stress, also about the smart soldering. We heard about that textured ribbon being applied by some manufacturers. But turning to the mechanical stress, Simon Meijer, you're the CEO from Coolback Technologies. You've developed your solution more or less, as I understand it, primarily to reduce the operating temperature of the module. But there are additional advantages when it comes to this mechanical stress issues, as Hongbin has brought up. Can you take me through those?
Thanks, Jonathan. Yes, of course, I can give you some explanation on how that works. Cooling was our first target of the solar module, and for that we increased the back surface of the solar module. And now with these larger cells and larger modules, you see that the impact of load and bending is really relevant. As Hongbin said, the module reliability is what counts, and the larger module actually is not that good on that point. But when we increased the backside surface of the solar module, we also increased the total strength of the module, and also did find a different solution for mounting the solar module. As Hongbin also said, you have 4 points to often attach the module to the rails. But if you have the full surface on the module available for connection, you can spread the stresses, you can spread the load, and in all dynamical load tests and static, mechanical, and dynamical load tests, you can see that spreading the pressures and the loads gives a huge effect on the modules.
Okay, and Simon, you've got a video. You've put together a video to kind of show how the Coolback system really does kind of deliver that additional rigidity and strength.
Exactly, and also to refer back to Jay Lin and George Touloupas' input, thinner glass is what we tested, and you can see in this video also in the end. And this is, of course, now just a 72 cell or 144 half-cut cell, but it's still a very nice comparison to see in this video what the Coolback structure can deliver. Go ahead, Jonathan. This is just walking on the standard module, and you see some breaking of cells. And when you start jumping on this is normal glass thickness, you lose 10-20% of your cells. This is the Coolback structure where you see the whole back is covered. And then jumping, nothing happens. And we have seen that we can reduce bending by 90%, in load test up to 7,000-8,000 Pascal. And this is a 2 millimeter glass. Tap dancing, I hope this makes very visible how this bending issue can be solved.
Yeah, very visible indeed. Thank you for that, Simon. But I don't think anyone advises jumping on modules at this stage.
No, that's definitely not what I want to say. But it's the most visible way to show how thin glass and with a nice EL, you can still see how module technology should make next steps in how it should look like.
Okay, excellent, Simon Meijer. Thank you very much for that. Josep, Tienda, I want to bring you into the conversation now. You're the VP Sales EMEA for Shoals, joining us from Spain. Now, we're very focused on the module here, but higher power means higher current, higher voltages. On the EBOS, the electrical balance of system basis, what kind of challenges do you see from Shoals?
From a manufacturing standpoint, we don't see any additional challenges because all our systems have been designed, tested, and with even higher current that we're seeing or higher powers. We do see some issues when we talk about installations at the field. Traditional methods of installation are gonna have an impact in the overall performance of that plant because we see that with this higher current and the power these models are gonna have, if you don't have installers doing the right job at the plant, you have an impact.
Okay, and while we are going through a few slides from our panelists, I'll give you an opportunity also just to take us through the Shoals solution or kind of the approach. I think you've got some images that kind of demonstrate a little bit the approach to EBOS that you're kind of bringing into the market more actively in Europe, shall we say.
Exactly. Right, so this is the traditional method of installing EBOS systems. And you would need certified electricians to do this job over and over in an install. So these guys need to lay, measure, strip the connector, crimp the connector, inspect that everything has been done well, and then install it. That repeat that 1,000 times every day by each one of the installers, and you're going to have a lot of issues going forward when you commission this plant, because you cannot guarantee that connection has been done the right way every time, right? So our solutions, which is the next slide, will show you that basically Shoals has a system that allows you to have customized EBOS built for your plant. We basically design a harness. The first part is the interconnect harness that you see in the middle. That's basically is going to put all the strings that you can put in parallel and bring that to a trunk DC system called BLA, which is going to allow you to get rid of the traditional combiner boxes that you would normally have. Okay, all of this comes in a plug and play manner. The only thing you need to worry is just to connect those string harness at the end of each string. That, by the way, those are protected, so that's why you don't need conventional combiner boxes. We have inline fuses in there, and that would allow you just to have at the end a disconnect box that is really simple and allows you to connect to the inverter easily without any issues. This is a on-air system. You don't need to have any work done with trenches or anything, and speeds the installation time by you only need 40% of the labor you would need to normally, and you can just accelerate the installation by 5 times. That has an impact on LCOE as well, because in the end, you just guaranteed that the energy yield and the plant is performing as the components were supposed to.
Okay, Josep, Tienda from Shoals, thank you very much for taking us through that. Cormac, Gilligan, you've been waiting very patiently. I'd like to bring you into the conversation. As we heard earlier from Eternal Sunspire, these large format modules are arriving in Europe now. How would you describe the kind of readiness for the industry? We've been very focused on the module, but of course there are impacts right across the supply chain, right across all the different market segments when it comes to an array. How ready are we?
Yeah, I think we've seen it. This trend towards larger power modules accelerating over last year and certainly into this year. When we look at the different parts of a solar system, I mean, everyone has been accelerating their development. So we've seen this across the solar tracker. So single axis trackers have been increasingly are being adopted, and they're having to work. And I think the panelists have mentioned everything to do with how you mount these larger modules. And this may mean that they have to tweak if they move from maybe having 2 portrait to 1 portrait to using maybe dual row trackers. So lots of innovation going on there. When we look at the inverter world, certainly things like being capable of having larger fuses or higher rated fuses to work with a lot of these higher power modules. And I think across the industry, we're seeing, and then this is one of the trends I think that's coming out of this panel is trying to move towards more standardization, simplification, so that as we move to maybe less number of units in the field, so maybe if we move towards larger modules, larger inverters, even string or central, they're moving to maybe 200 kilowatt and above or 6 megawatt and above. So we're really trying to make it a more efficient process for installing, particularly when we're looking at ground mount. And what we're trying to really do is certainly tackle the labor cost and certainly the reliability. And I think this is everyone in the industry is working towards this. And most of the manufacturers are working in partnership together, the module players and lots of the other parts of the balance of system to do it efficiently and economically.
Okay, thank you very much for that, Cormac. Frédéric, I understand that we have quite a lot of questions coming in from our attendees. So shall we get to those as quickly as we can?
Yes, Jonathan. Our attendees have been sending in quite a few questions. So the first one that's ranking top right now, do you believe that PV modules can protect agricultural products from bad weather when they become more fragile?
Shall we? Maybe Cormac, I'll throw that one to you. Agri-PV is one of the kind of, it is an emerging kind of market segment, still niche at this time. Are modules strong enough to protect the crops?
Well, I think a lot of the considerations, particularly when we look at a structural balance system, when we look at, I guess it depends if it's vertically or horizontally aligned. And it's certainly a big topic, I know in France and in other parts of Europe, the movement towards that to utilize more land and get additional benefits. I think most of the players in the market, I don't think they're overly worried about the robustness of large format modules. I think a lot of people in the market are really trying to optimize everything to do with if it's let's say having them raised off the ground, it's maybe trying to ensure that there's benefits like bifacial gains are really enhanced. And yes, if they're used around livestock, I guess it's just to be very careful and make sure there's enough space. But I think there's enough people in the market now trying to push this that I think it'll be not a big problem.
Okay, thanks for that, Cormac. Actually, talking about EBOS, you mentioned livestock. While we're talking agri-PV, Josep, I'll bring you in here. Shoals has a huge track record in the US market, but in Europe, I think agri-PV may kind of move a little bit faster. What about kind of EBOS solutions for agri-PV? I imagine you need things to be safer than usual, cables to be handled very safely.
Yeah, I mean, it's all about the height as well, how you're going to position those solutions. Depending what the requirements are, sometimes as you know, we can also, even though our BLA, for example, has been designed as a open air solution. You can also just vary them. So as I said before, Shoals' mentality is just to do a customized solution that adapts its best to the system requirements and helps our customers to reduce cost of installation and total cost of material. So we will see the plan, we will understand what the requirements is, and we'll design the best solution.
Okay, well, direct burial, as it happens, has been one of those themes that comes up regularly on our quality events. Frederica, more questions from our attendees.
Yes, I think this one is for you, Hongbin. Which sample percentage, which sample/% are relevant for on-site EL testing to be considered as a valid guarantee claim by a module manufacturer? So,
I guess.
Yeah, please.
I guess that would depends on the nature of the claim, right? And what kind of defect are being claimed, on the modules. And so these are definitely right now there are a lot of on-site tools that can be used to evaluate, to validate the claim, validate the issues on the module, right? So I guess this is we're more than happy to work with all the players like third-party inspectors to try to understand the troubleshoot on the problem and try to understand the issues and then get the claims resolved as soon as possible.
Okay, thanks, Hongbin. There's another question from an attendee. Is there any possibility to see a 30-plus year PV module lifetime in the next years? From your side, what do you think?
I guess, the current and for the bifacial modules, right, with the double glass lamination, and the conventional, I think, thinking that people, we warranty the modules, at least, through like 30 years, right? And actually, we do not expect the module going to go, abruptly, go dead, after 30 years. Should have some extended reliability after that. And on this regard, I guess the industry is continuously evaluating, how to test it, how to correlate the accelerated testing with the field performance, the lifetime of the module. I guess that's a project I think the industry is working together, and definitely I think there are also discussions about 40-year, life, for the modules, and seems like if the material you choose the right material and going through, extended, testing. And there are some experts in the industry think, the modules can last probably even, more than 40 years.
Okay,
And
Simon, can I throw that over to you as well? Oh, sorry for that. Simon, over to you on that.
Yeah, the testing referred to, we did together with Fraunhofer Institute in Germany. And the modules equipped with Coolback are having a guaranteed lifetime of 30 years. Indeed, because degradation is simply lower by making the right choices on materials, design. So definitely the replacement of a frame by another structure as Coolback will extend lifetime, 30 years easily.
Okay, materials important there. Frederica?
Yeah, and also the process, just want to add one point here,
sure thing.
Right? If look at the process like a smart soldering, that enables, minimize the microcrack formation, which going to, help elongate the lifetime of the module as well, right? So there are a lot of technologies that are being developed, being, deployed, and that probably going to help extend the lifetime of the module.
Mm-hmm. Okay, thanks to both of you.
Yeah, we actually have more attendee questions coming in. Oh, I'm stumbling there. The first one right now is, in your experience, do manufacturers rigorously sort out cracked cells? So how rigorous do you go about sorting out the cracked cells? Hongbin, maybe you can give us some feedback there.
Sure, I think the cracked cells definitely there is a spec, right? And we have a SOP, we have an internal control spec with regard to what is acceptable, what is not. I think we have been working with the third parties like a CEA and to develop some they call the golden standard, right? And so definitely, if the module the cracks is larger than what's being allowed. In the standard, and those cells will be reworked, and if cannot be reworked, the modules will be put on the side, right? So definitely extensive. I think normally at least the whole module will go through at least twice full size EL, and doing the manufacturing process, right? So I think so once before, once after the animation, so that will help ensure, minimize the crack formation that exists on the finished good.
Okay, thank you for that, Hongbin. We have a question about kind of 182 millimeter or 210 millimeter cell modules. Naturally, this is a point of debate, and I think Longi's perspective on this is pretty well understood. But Cormac, I want to throw this one to you. What's your understanding in terms of the BOS savings with these different cell and then module formats? You know, we're seeing a lot of tests, but what's your feeling about what delivers the lowest LCOE in Europe at this stage, I suppose?
Yeah, I think like most things, it comes down to specific sites as well, and weather conditions and things like that throughout Europe. So, typically a lot of the developers will have to be considered to that, and if they use different components and how. I think the trick at this stage is that everything has become so sophisticated that integrating them all, inverters, EBOS, trackers, so your structural balance of system, along with the new module technology, where all of that has to be, and choosing which type of module potentially has to be weighed up against current market dynamics. And I think everyone in the marketplace right now is probably the market is moving more towards when supply might become available, lead times, guarantee of supply. So there's lots of other externalities that need to be considered apart from the technology at this moment. But even then, it's just maybe that little bit too early to say, just based on the amount that's been installed.
Okay, so we're still at early days yet, so there's going to be different opinions. One last question, Frédéric, and then let's move forward.
Yes, we actually having the question. This one is going to you, Simon. Actually, our attendees are wondering, modules are moving towards bifacial. How does the Coolback system apply there?
There is a large monofacial market, and there Coolback is available at this moment. And that's still bigger than 50-60% of the market, so that's our focus. And bifacial has some other advantages, but yeah, can't have it all.
Indeed. Actually, I said last question, but we have one more coming through. Josep, so you're really not at Shoals seeing any challenges when it comes to the connectors themselves with higher power modules? This was another question from our attendees.
Yeah, we don't see any issues because we're using the best technology out there right now when it comes to connectors. And for example, the Stäubli connectors are rated to cope with even 69 amps when you talk about 10 millimeter square cables. They have significant lower contact resistance, higher current range. You can select broader cable selections. So in the end, if the components, if the connectors are from a quality vendor, for example, Stäubli, we don't see any issues coming from that bit.
Okay, thank you very much, Josep. And in fact, our quality case study that will be coming up very shortly will be addressing cables and connectors, so stick around for that.
Yeah, and that was all the time we have for our panel. Thank you to our panelists, Hongbin Fang from Longi Solar, Cormac Gilligan from IHS Markit, Simon Meijer from Coolback Company, and Josep Tienda from Shoals Technologies.
Well, of course, on the system level, as we heard as a part of that discussion, there are challenges with large format modules, and that also applies to power electronics, which we haven't really addressed in any detail quite yet. So let's get that perspective now. Shenzhen-based Growatt has been one of the fast-growing inverter manufacturers in recent years. And while it primarily serves the rooftop segment, there are expectations that high-powered modules can find a place in C&I arrays, where everyone knows the competition on cost in the C&I segment is fierce. Growatt's new Generation X series meets that demand, and we'll hear about it next. In expectation of increasing demand right across its range, Growatt has built a huge new manufacturing facility that will be capable of serving 20 gigawatts of demand annually. That's from the single site. Taking us inside this new facility and Growatt's quality program is Robert van Koon, a technical manager at Growatt. Robert, welcome to Roundtables Europe today.
Hello, thank you, Jonathan.
And thanks for your time. Please take us inside this new production facility and also the Generation X series.
Sure, I will. Thank you. Let's see. I think you should be able to see my presentation right now. Hello, everyone. I'm technical manager at Growatt, and I'm excited to tell you more on how we can guarantee our high quality products. We just saw some of the latest technologies when it comes to modules, but of course, without an inverter, there's not much you can do with the modules, and that is where Growatt comes in. Not sure why it's not going to the next slide. Well, hopefully it doesn't. Yeah. The quality of our products is one of our highest priorities. Yes. Sorry about that. As mentioned before this morning, the format of power modules are getting larger. With this knowledge, we have increased the maximum input current of our new generation inverters, the X generation, to make sure they can handle the large format modules. Over here, you can see two examples of our products. On the left is the Min TLXH, which is a hybrid inverter. And on the right, you can see our Max inverter with a maximum power of 125 kilowatts. The Min TLXH can handle a current of up to 13.5 amperes. The Max inverter can handle up to 16 amperes. This makes our inverters perfectly compatible with high power modules of 500 watts and up. Also, our inverters and our batteries have received multiple awards from PV Magazine and TÜV Rheinland. For the last 5 years, Growatt's growth has been exponential. Our shipments have multiplied by 6.5 times, from 1.6 gigawatts in 2016 to 10.5 gigawatts in 2020. According to research done by IHS Markit, Growatt is the second biggest supplier in the residential market. We also have been awarded by EUPD with the Top Brand PV Inverters Award in 9 different countries. What is our success? Well, one of the reasons is our high standard when it comes to quality checks. Even when producing such large numbers of inverters, we still aim for the highest quality possible on every single unit that leaves our factory. I will tell you a bit more on that right now. To ensure the quality and reliability at such large scale, we use a 5-step quality check system. Like any other product, we start with design engineering, done by our research and development team. At this stage, the circuit boards are designed and tested, as well as the software. The structure is designed, and to make sure there is an optimal heat dissipation, we run a thermal simulation. The next step is engineering all the components. During the selection, we aim for the highest quality components and test them using sophisticated lab tools such as metallographic microscopes and stereo microscopes to screen for any deficiencies. If a component fails during one of the tests, this is thoroughly analyzed to find the cause. After the components have passed all the individual tests, it is time to test the complete product. Besides testing the structure, power circuit boards, a stress, performance, and function test, the products also go through more than 20 certification systems adopted by various countries in the world. Since PV inverters must perform reliably for many years, long-term reliability tests validate Growatt's inverters continue to function in a reliable manner, even in challenging environments. The final quality check is to test every step in the fully automated production process. The component, function, and environment reliability tests are managed and checked by our dedicated product reliability management department. They make sure every step is thoroughly executed. Last year, PV Magazine wrote an article on our 5-step system, which is also published on our website. So for more details, you can check the website of PV Magazine. To keep up with recent developments regarding the production process, Growatt recently opened a new advanced manufacturing center. With the help of a fully automated production line, we are capable of producing 20 gigawatts annually under the highest quality standards. The factory is optimized to execute our 5-step quality system. And to give you some insight on the factory and its capabilities, we will show you a video. As you can see in the video, we use the latest technologies and robots in our production line and warehouse. This guarantees the quality consistency on every single product. Please start the video. Thank you. All right, hopefully that gives you an insight on our new manufacturer, and I hope you like the music. With over 2.6 million inverters installed globally in the past decade, Growatt has proven itself being capable of keeping up with the highest standards in the industry. Our newest X generation inverters are perfectly compatible with 500 watts and up high power modules, together with integrated AFCI, anti-PID, SPD functions, and the 5-step quality system, we can guarantee a safe and high quality product. Thank you for your attention. And if you have any questions, I will be happy to answer them.
Thank you, Robert, and thanks for that basically sneak peek at your new manufacturing Fang facility.
Sure.
Did you yourself manage to visit it yet in Corona times?
No,
Not yet?
unfortunately, not yet. No.
Well,
hopefully soon.
Hopefully soon, exactly. So, Robert, tell us more about the 5-step quality system. Are you continuously improving on it? And does it adapt to the evolution and development of the market, for example, the large module formats that we've just heard about?
Yes, of course, development is going fast, and we're keeping up. Even with the high format modules, we aim for a higher voltage, maximum voltage, and higher current to be perfectly compatible with the high format modules. Yes.
All right, and you've scaled up quite a lot in 2020, and is the quality system able to keep pace with it?
Yes, it is one of our highest priorities. Of course, and it's more difficult the more you produce, but that's why we have a dedicated team to keep an eye on that. Yeah, every single unit, even at this large scale, is still monitored and thoroughly executed. Yes.
Great. And also an attendee question asking for clarification. Can you tell us what AFCI integration means?
Yes, AFCI is the lightning protection. When the lightning strikes the panels, the inverter will shut itself off, shut down to prevent any damage and possibly even causing a fire.
Okay, thanks for clarifying that. And actually, can you tell us a bit more about the quality system in itself? What happens when one step is not passed? Do the steps also in that manufacturing facility work in parallel, or do they work in order?
They work in order, but when some of the tests do not complete, it's not completed, when not successful, it is thoroughly analyzed. What is the main cause of the failure, and to prevent any more failures, for the upcoming production. So yeah, as soon as we find a failure, it is immediately analyzed and solved.
Good to know. And our attendees are asking about white panels. Do you have any information on developments in that regard?
You mean manufacturing panels in general?
White
like
panels,
robots?
yes, I assume
White
so.
panels.
It's a very short question, so let's assume.
I'm not sure. I think we haven't specifically designed our products on white panels yet, but we definitely are looking into it. And our engineering and testing at our test facility.
Great. And as a last question, we have the question, will system voltages increase above 1,500 volts?
Not yet. The highest voltage of our max inverters right now is 1100 volts. Of course, also on that part, we are constantly developing to accept a higher voltage. And hopefully in the near future, our big inverters will accept 1500 volts, yes.
All right, we actually just got one more question in, Robert. Which is the most efficient inverter, in your opinion? Is it central or string inverter?
To our opinion, it's string inverter. There's a lot to say about it, a lot of different opinions. But yeah, for every other device, it also takes power from potentially going to your own load. It takes the power away, and with string inverters, you get the highest efficiency. Yeah.
Great, thank you, Robert. This was Robert van Keulen, Technical Manager at Growatt.
Thank you.
And before we get to our second panel of the day, we will hear from my co-moderator and PV Magazine Global Editor-in-Chief, Jonathan Gifford. He will share a quality case study with us covering an uncommon cabling incident in a German utility scale. Jonathan, the stage is yours.
Thank you very much for that, Frederica, and an interesting discussion. Really diverse questions coming from our attendees. White modules, kind of pointing towards growth in the BIPV segment, which is one that Growatt will be addressing. That's kind of interesting. Now, moving forward, quality case studies, as I said right at the top, they've always been a part of what we do on our quality events right around the world, and we're calling our case study today Unplugged, when uncommon cable solutions go bad. Let's go through the details. Solartechnik Bayern was the company that provided independent engineering services on a 4.3 megawatt utility scale array and the company was then retained as the O&M provider. The park was constructed in 2016, owned by a group of independent investors. Christian Bieber from Solartechnik Bayer, he got in touch with us at PV Magazine and is pictured here. The project is located approximately 250 kilometers north of Berlin. It deployed 250 to 270 watt peak multi-crystalline modules from a European supplier. The modules were equipped with one 4mm squared male cable coupler and one female cabler. You can see, female coupler, I'm sorry. You can see actually on the diagram here, the system that's actually from the module data sheet. And this is really the point of some controversy. The diagram kind of shows that we have one cable and then just really the socket, the female coupler on the other side of the junction box. The reason for the controversy is that Bieber reports that the park began encountering problems with the connectors. He said that he found unmated connectors and that they were becoming loose over time through thermodynamic effects, so cold in winter, hot in summer. As a result, the connectors have degraded, there are contacting problems, and there's even the risk of fire. We've been in touch with the module manufacturer and cable supplier, and of course, we've got some different responses, differing responses. You can see some of them up here behind me. Central to the case, it seems, is the installation methodology itself. Bieber and his team reports that the cables require 2 audible clicks to be properly mated when the mounting clips on the connectors kind of come into place. However, the installation instructions state that only 1 click is required for the mating to have been successful. You can see on this close-up picture the mounting clips themselves. Bieber responds that sometimes the mounting clips can clip flush into place simultaneously. So then just 1 click is heard. But other times it requires a bit of turning or wiggling to get them into place, hence 2 clicks. The cable supplier's instructions really state that only 1 click is needed, and then both mounting clips are to be in place. It's conceivable then that only one of them is in place when the single click is heard. This is a lot of information about clicks, but it's kind of important as those failure points have shown. And Solartechnik Bayern says that it requires 100 to 150 cables a year to carry out O&M on the park. Up until 2021, the module manufacturer did provide these cables for purchase by the park operator. However, as of this year, Solartechnik Bayern has been told that A, the cables are no longer in production, and B, that the module producer requires the replacement cables that it has itself. To replace the cables or to repair the cables without actually replacing them, Solartechnik Bayern says that it will take 4 hours per module to uninstall the module, to open up the JB, solder the cable directly inside, close the JB, seal it with silicon. So you can see there's a lot of steps. He says it's just prohibitively expensive to do so. And further complicating things at this particular project is that the mounting structures are very low to the ground. Modules are only 50 centimeters off the grass. So in terms of ongoing warranty support, it kind of appears like this case slipped through the cracks. While Bieber was trying to get the cables, the issue really wasn't registered as a warranty claim with the module manufacturer, so they report, and the cable supplier tells us that they have just no records of it at all. Some good news, I'm happy to report now that it appears that all parties are moving forward to find a resolution. But it really shows that there has been lost power output, there is the risk of fire, there's ongoing O&M hassles, and of course kind of sustainability issues, because if there is burning JBs, you can't repair these modules, they really need to be replaced. And overall, all of this really didn't need to happen. So let's get together our panel of experts to discuss this case.
For our panel, Don't Transfer, Manage, Tackling Risks as Technologies Change, we welcome the 3 experts. We heard from one of them earlier, Frédéric Dross, VP of Strategic Development at Synergy Technical Services, also known as STS. On top of over 15 years industry experience, Frédéric has authored 80 scientific papers, peer-reviewed international papers, 6 technology white papers, and 8 patents. Welcome back, Frédéric. We also welcome Ragnar Schmidt-Haupt, partner at Everrose. Over the last 15 plus years in the industry, she gained and shared her profound experience while working in Europe, Asia Pacific, Africa, and South America. And we also welcome Andrea Viaro. Andrea has been involved in the industry for over 12 years and is utilizing his deep knowledge about PV technology in his current role as Head of Sales EMEA Alternative Energy at Stäubli Electrical Connectors. Welcome, everyone. We're looking forward to hearing from you.
We've just heard there's a small problem connecting with Frédéric, so hopefully we can get him back live very shortly. Well, we have seen the case. We've seen how these kind of problems have developed. It's only a small project, but it's kind of a big headache if it's your project, right? Andrea Viaro from Stäubli, you know, we do hear that cables and connectors, while a small component, can cause kind of big problems. What's your takeaway in terms of this case, and how kind of risk has been shared amongst the project partners and suppliers?
Yeah, Jonathan, thank you. And actually, to be participating also to this edition of the PV Magazine Quality Roundtables. It's an interesting case study because clearly shows, as you said, how risk is still a topic and has to be controlled, shared, mitigated, I would rather say, if possible. And clearly, from our point of view, starting from the components or PV product supplier standpoint, clearly the first step is having a proper design and engineering and production of the components that are ultimately used for the PV module assembly and then installation in the field and during operation. So this is a long journey for even small components like a connector, and there is a lot of aspects that actually are important to be considered. The material itself, or even in this example, the double click feature of the connection, for instance, which created some confusion, we understand in this case, with the installer on whether the connectors were properly plugged or not, with the intent, of course, of the PV module supplier to optimize the design of the installation, possibly, or reducing the waste of cables, even, which is a good principle in the beginning. But then we see how during the operation and maintenance of the plant generates additional hassles or troubles and costs, ultimately affect the overall balance of the LCOE of the plant. Just from the engineering or technical point of view, even the fact that all the stress of the connection is concentrated in this solution on the contact point, because the cable is going inserted into the junction box directly, somehow hides how this could be possibly a weak point of this design of this solution. So I think in general, whenever there is unusual or, let's say, innovative but solutions proposed to the market, it's even more important to make sure that the products are well understood by the complete value chain, starting from the PV module assembler, manufacturer, clearly, to make sure that the components are properly assembled into the final product, but also to inform and train the installer, the EPCs, on the proper installation, handling, and assembly on site. So it's a complete support that clearly is needed by all the manufacturers, like us in this case, to make sure that all the stakeholders, all the parties are completely aware of the proper assembly and handling of the products. It's clearly challenging to cover all the aspects, also from our side, as despite the complete value chain, many times we not able to reach granularly all the players in the industry. But clearly, a big role is played by our support that we give to the PV manufacturers, starting first in the beginning on, as I said, the proper installation and assembly of our products onto their products, and then to, for instance, to assure, like relevant for this example, that spare parts are available during the complete operation of the PV plant and much beyond that, with solutions which are compatible and possibly being able to be replaced and used for repair on site and or possible revamping or repowering of the plant. And then, of course, not to be disregarded, the support on solving problems, which also for manufacturers of EBOS components like we are, is important, and this example is clear on the support that we can give to the PV manufacturers, but also to the end users, the installers, to solve together the problems on site and not really to leave them, as many times happen, unfortunately, for recent reasons, alone, so to say, but really to work together to reduce the risk and to mitigate the problems that they might have on sites. So therefore, there is really a lot of stages and ways to reduce and mitigate the risk. First of all, to provide solutions which are easy and reliable to handle on sites. That's what the customers and EPCs need, the installers need in first place, but also facilitating the control of the risk and the mitigation of the risk on site because of local assembly, on-site assembly, as was highlighted also by Josep from Shoals earlier in the previous session, because this clearly increases the risk of potential failures on site. So by doing more and more assembly in the factories and providing complete solutions, it's possibly a way to also reduce risks from the supplier side.
Okay, Andrea, thank you very much for that. Frédéric, I'm glad that we could get you back online again. I'll go straight to you. No time to settle in. What about on the procurement phase then? How could have the kind of risks that ended up causing these problems with the case study, how could have that been addressed in the procurement phase?
Right. So there are a couple of things that we do for our customers on the procurement during the procurement phase. The first thing that a customer receives when they hire us for that would be an assessment of the risk associated with each component of the bill of material of the modules, and this is clearly one of the components of the modules. So this BOM risk assessment, we use information coming from different channels for that. The first one are test results, simply, having, and this is probing typically the design of of either the module or each of the components. But okay, maybe test results were not available, or it's possible. It happens sometimes that we don't have the information that we need, as in terms of third-party test results. It's not always easy to have. Second channel that we have is known bad materials. There are a couple of bad materials that we know about because we've seen that either in the field ourselves, or I've seen reports of these. So we know that some materials should be looked carefully before being accepted into a bill of material. But then again, we don't have all the catalog of all the bad materials that have ever existed. So it's possible that we would not have had this information. And the third thing that we are looking at when we're doing a bill of material risk assessment is the prevalence of the components in the industry. So because we have boots on the ground, at gigawatts of manufacturing, and we are present, days in, days out. So at the moment we speak, I'm sure that we have several many workshops that we are inspecting in parallel. Actually, we keep a track of all the bill of material, all the materials that have been used in the different modules, and we know that some are more common than others. So that's one thing that it's a proxy. It doesn't tell everything, but an exotic material would be a red flag, and in this case, it would have deserved a little bit more scrutiny, probably at this point. So that's the first part, and that is really risk assessment of the bill of material. Another thing that we do at this stage of procurement is sometimes we don't have all access to a lot of tests. However, what we can do, and it's actually a service which is gaining a lot of popularity with new evolving technologies, is what we call a product development review. In a product development review, what you do, you are evaluating the way the product was developed. Because there's a good way and there's a bad way of developing a product. If you follow all the steps of development, you should capture this kind of risk. You should have a solid FMEA, so failure mode and effect analysis, and you should capture, for instance, that an operator error is a possible mode of failure, and this has to be taken into account. So by identifying, by studying how the product was developed, you can identify whether all the risks have been tackled and whether there are some gaps. And if there are some gaps that we identify, that's where you want to put the scrutiny. So that is on the part of the module. And there's one last thing that could have been done one last thing that could have prevented this. And I think this is happening in the field. During installation, when we do construction monitoring, typically, we do many things, and among those, we do two things. One of them is we check the SOPs of the EPC, and we verify that the SOPs, so the standard operating procedures of the workers on site, we check first that they are compatible with the manufacturer's instruction. So I think this already, I'm not sure exactly what happened, but this is a check which is very important. And then the second thing, we check that the operators, the people that are really on the ground, are they really trained towards the SOPs? And this translativity, between manufacturers' instructions, SOPs, and operator training, all this chain of translativity, this is something that we check. I believe that in this case, if the operator was not waiting for the second click systematically, there must have been somewhere this link broken. So I think this is where we could have caught it as well.
So there are multiple opportunities and multiple tools that you can use to kind of catch these things at the procurement stage. Ragnar Schmidt-Haupt from Everose, I'd like to bring you into the conversation now. As an independent engineer, what kind of would have been the red flags for you? What would have shown up for you as something that needed taking action, and what action would have you taken?
Thanks, Jonathan, for this question, and also hi to everyone around the world. Exciting conference. Yeah, so as a technical advisor, we really are taking the long-term view. The project lifetime of this project is 20 years, maybe longer, depending on the assumptions that the investors or the lenders would like to take. And so very often we tend to look really at the very beginning of the project lifetime, the development phase or the procurement and the construction phase, and tend to forget the very long period of operations. And so we really try to make sure to bring back this long-term view. So while Frédéric has already nicely covered some of these aspects during procurement and development phase, where we would also, as during the technical due diligence, would request some documents around product certification, or if there has been anything done around factory audits, we would then go and dig in a bit more detail into the warranties provided. So this is clearly a case where the component warranty is not being fulfilled, or there are discussions around whose warranty is it? Is it more the installer's fault, or is it actually really a component case? But typically, we have to admit that some of the basic manufacturer warranties are sometimes weak, and it's not always possible to get them back during these cases. Another important aspect that we would check during due diligence is, as Frédéric already mentioned, is spare parts policy, both on site and also at the factory. However, in this case, it's really a problem also around this unique connection method. So even if that one supplier is not available anymore, after a couple of years' time, which has happened here, what could be the replacement options? And maybe this may have fallen through the cracks during the due diligence process here to see that it is difficult to replace it. And now the supplier is not providing these cables anymore. So after the spare part policy, one of the important topics that we cover is scrutinizing the O&M policy, O&M scope, O&M cost. Is it full scope or is it like a reduced cost and scope? And based on that, come up with assumptions around the maintenance reserve account. Maintenance reserve account, most of you will be familiar, is what the lender requires as a buffer within the SPV to accrue for costs that may be expected in the future. So this would normally cover some of the costs of these connectors, or as seen in the worst case, the whole module to replace, including the intervention costs. However, even within assessing an MRA, no one would assume a replacement of all these modules due to those connectors. So even a very onerous MRA would probably not have done that. And ultimately, I think one of the important topics here, and as Frédéric already mentioned, is the role of the owner's engineer. Like Evero's subsidiary Skyray, as an owner's engineer, would make sure then to really be there present during the installation process and make sure that the information gained during, for example, the due diligence phase, having seen there is a red flag or an orange flag around this very unique connector, that the installation advice provided is followed by the installers. In this case, the installer is not undertaking the O&M, which helps in many cases, because then again you get back into this very long-term view of the 20 plus years project lifetime. The technical advisor took over the owner's engineer role, so where you see there may have been a gap again, which would have required some scrutiny. And then again, I guess the next step comes really during operations. Are there regular performance check? How is the monitoring happening? How quick has the response to be undertaken, or are there penalties if there's a late response, and what are the scheduled maintenance? And could these issues maybe have been flagged earlier to avoid fire risk? Could these have been maybe the double click? Could this maybe after half a year or a year already been reviewed for all of these? So I think very thorough or an O&M schedule and a monitoring of the performance plus scheduled maintenance may have possibly helped to prevent losses. It's good to hear that, as you mentioned already, Jonathan, the parties are moving forward. So there's clearly a need in this situation to find an agreement, especially with three at least, maybe 4 different points of view, but maybe also to give a little bit of background. We do see these situations also in other cases. One very good example is, for example, with cable ties that are used to attach solar cables to the structure beams at the back of the structure. They're not designed for a 20-year plus design life, especially not in harsh environments. And when some of these ties start breaking, it puts extra weight on the other ties, which end up breaking as well. And at the end, your strings are laying on the ground, which is a serious HNS health and safety issue. So there are a lot of other small components we tend to forget when we look at these projects that may cause some of these issues.
Yeah, details matter. Thank you very much, Ragnar, for that answer. Frederica, we have lots of questions coming in, so let's do a kind of quick fire question and answer round with all of our panelists.
I was just about to say, thank you, Jonathan. So, Andrea, I think this one goes to you. Do these kind of uncommon connectors appear as commonly on the market still in 2021? Are there similar products available today?
Well, not really. We have to say that those solutions have been a kind of discontinued. There is probably still in the market one main module supplier which is still using this kind of solution, but it's definitely on a different level of quality and reliability, which is still on a split junction box design with connectorized solution, which then allows to customize the cable length depending on the installation design, but generally the standard solutions are really having plug and play design of PV modules with cable leads already attached to the junction box.
And Frédéric, our attendees are wondering, this cable and connector was described as uncommon, but would it have cleared existing standards?
Yeah, it's possible that it does. You know, the standards, the IEC standards are usually quite low bar. So it's you know, I don't know in this particular case, but I would not be surprised if a solution passes a standard, clears a standard, but yet is not adapted to a 30-year lifetime in the field. I would not be surprised about that.
Thank you. And a question to you, Ragnar. To discover hot plug connectors, one of our attendees says they use sometimes they use thermal camera, and they're wondering if they can know what are the temperature limits of maximum and minimum for those.
Oh, that's a really good question, which I would have to probably discuss with one of my colleagues who would walk around with a thermal camera on a field. So happy to pass that and respond after this session.
Great. And then we have one more question about what would be needed for a successful warranty claim in a case like this when installation and product fault is disputed. Can one of you has an opinion?
Yep. Ragnar, to you first.
Yes, I think in some cases you would probably get the advice of a technical advisor who would well try to dig in. Is like a little bit of a detective's work. Dig in and go back and whose fault it is. And here we clearly have different views, and the technical advisor, owners, engineers would have to have an independent opinion on that and provide a legal paper that can be used. And then there probably you have legal papers from different sides. Depending on who on the other side is sitting, and depending on the country again, it's easier to then come up with a joint solution with all parties at the table, which seems to be happening, then go down the legal case route.
Great, Ragnar. Thank you for that brief insight. That was it for this panel. So thank you all three for sharing your expertise today. Frédéric Dross from STS, Ragnar Schmidt-Haupt from Everose, and Andrea Viaro from Stäubli Electrical Connectors.
And scampering into position, we're now coming to the end of our event. I'm terribly sorry we are running a tiny bit late, but we've had great discussions. And thank you very much for sending through your questions. One question that we did have somewhat repeatedly during that that discussion was, can we name the module manufacturer or cable supplier? And that's not really in the spirit of our quality events here at PV Magazine. Over the years, we've really stuck to, it's not about naming and shaming. It's really about learning, sharing the experience, and discussing these matters. So I hope that answers your question. And much of our quality discussion today has been kind of more on conventional aspects of quality. That's manufacturing, installation, O&M, warranty claims, and the like. But 2021 has seen a number of different aspects of quality become more important. Things like supply chains, which are in focus really like never before, and sustainability matters, from employees right through to end of life. So I'm pleased now to welcome the Chief Legal Officer of Maxeon Solar Technologies onto the stage. Maxeon, if you're not aware, is a manufacturing spin-off from US-based supplier SunPower, particularly for its P-type shingled module series. Lindsey Wiedmann was with SunPower for more than 10 years, where she ended up leading the company's global legal and sustainability teams. She was also SunPower's attorney at development spin-off 8.3 Energy Partners, and she brings a long track record with ESG issues to our roundtable today. Lindsey, welcome to Roundtables Europe. Thanks so much for your time.
Thank you very much. And thanks everyone for joining. As mentioned, and many of you know, Maxion Solar Technologies is the spin-off of SunPower, when SunPower spun its non-US business late last summer. Maxion's a bit unique in that we're headquartered in Singapore, where I just recently moved, and yet we're listed on NASDAQ. And our two largest shareholders are Total and then TZS, which is one of the world's largest wafer manufacturers located in China. And really the thesis of our company and the creation of Maxion was to bring the Silicon Valley US innovation strength together with Chinese manufacturing at scale, and to bring that to a partnership to really set up a solar company that is well set for the future of solar. And when I talk about the future of solar, I think we're all very keenly aware that renewables and behind that solar is going to overtake coal in the next few years as the largest producer of electricity. So there's certainly a huge growth opportunity for solar that continues. But what we think about at Maxion is that there's a responsibility that our solar industry has, that when we grow with this tremendous opportunity, that we do it in a sustainable and thoughtful way, that we're really taking into account future generations. There's not going to be a market where solar is not going to be there, right? And you can see from our map here that Maxion has manufacturing facilities around the globe. That helps us be close to our customers. We can help them, get solar faster and meet their renewable goals. It also helps from a logistics standpoint, which I think many of us have experienced fairly acutely during COVID. That cost and reliability in logistics has actually been quite a challenge. And then you'll also see that we have R&D in both through our partnership with SunPower in the United States and then also in Singapore, really building upon this partnership at a global level. So when we were splitting from SunPower, we really wanted to reset our corporate values. We're really proud of our legacy with SunPower. SunPower was a trailblazer in sustainable manufacturing, and frankly, before people really prioritized it or thought too much about it. It was really in the DNA of SunPower. But Maxion's a global company, and so as we, took a step back and thought about what we want our company to be, the first thing we did was to sign on to the UN Global Compact and its 10 principles. And together with that, we also adopted 4 Sustainable Development Goals called SDGs. You'll see that, we challenged ourselves. We said, okay, we're in the renewable business. We make solar, which is, I think, one of the biggest problems we're facing. But we challenged ourselves to address other things. So we wanted to be sure that our activities, both in our company and our communities, improved equality. We wanted to be sure that all of the way we govern ourselves, what we expect of our supply chain, as mentioned earlier, that's certainly been a relevant issue in the solar industry, that all of those are held to best of class and align with the principles in the UN Global Compact. And then finally, we wanted to ensure that in our manufacturing processes and operations, sustainability was a factor and an important factor, in addition to the traditional things we focus on like cost and efficiency. So we signed the UN Global Compact and its underlying principles because at Maxion, our priority is really to be the global corporate citizen that all of our stakeholders expect and that I think our future generations deserve. And for our future generations, producing solar modules in a sustainable way is critical. It's not enough anymore that we're making solar and offsetting carbon and fighting climate change. We have a favorite saying at Maxion that our solar panels are as clean as the energy they produce. And it's true. You can see here in the middle of the slide, the font might be a little small for you, but what those graphs represent is a 4-year trend in manufacturing of carbon emissions, water usage, and energy usage. And what you can see from this graph is that we have been maniacal about reducing our footprint as we manufacture. We also think about sustainability in when we build our facilities. So 5 of our facilities are LEED certified. And I will say my favorite bragging right, I'll call it, is that we have Solar's first and only zero waste landfill facility. So as my children continue to be traumatized by using straws, it's certainly something close to my heart that, as manufacturers, we really have to think about what we're putting in our landfills in addition to the products we're creating. The last thing I would note is that we are also the only solar panels that have a declare label. And so what that means is that we're fully transparent about our ingredients, what's in our panels, similar to the ingredients in your food, right? You want to know what's in your food. Well, our customers deserve to know what's in the panel. And it really is, thinking a few generations out or decades out as to when these panels are end of life, really what's inside. And then in addition to manufacturing, we are also constantly thinking about how do we get more solar on the planet and how do we do that in a sustainable way? And the reason's really simple. More panels is less carbon. I think that's why we're all in the business and dedicate our lives to this important cause. What I've noticed moving here to Asia is that there's so much opportunity for solar. There's so many roofs that aren't, your standard roof that could hold a solar system. And there's so many other applications. And I do think as a solar industry, we have to continue to make solar more and more accessible. We've been doing that through cost reduction. And the reality is we've been very successful at doing that. But we need to start thinking about different applications, not just cost. And that's why we're so excited about Maxion Air. I can tell you that I love this product. It opens up completely new markets for us, new roofs, new customers. There's going to be more solar. It's light and it's easy to install, and yet a customer will get the same reliability and power that they expect from Maxion products. But what really strikes me about this product is the other piece of sustainability. There's simply less that's needed to get this panel from our factory to powering a roof or other application. There's less transport and logistics. It's thin, it's light. There's less installation. With less installation, you go to the site less times, less road trips, and you can imagine all of the ancillary impacts. There's also less material in the system itself. There's less in the panel, there's no glass, but there's also less BOS because there's no racking. So when you start to take a step back and think about innovations like Maxion Air, they really do have that follow-on effect of sustainability. And at Maxion, what we think about is that we have to continue to innovate as an industry to fight climate change. So I've told you a lot about things we're working on at Maxion and how we approach our ESG program and sustainability in general. But I did want to let you know that we are going to be publishing our first sustainability report as an independent company. It'll be coming out later this month. And we went through a very robust process as we developed our ESG program and our material topics. And the reason we did that is we think it's really important to take all of the input of stakeholders into account, because the reality is an ESG program, you know, it's at the heart of our company and Fang as to what you do, and you need that investment. You need that collective action for it to be successful. So we also structured a program, as you'll see here, with that we want to have best practice and also that will stand the test of time as ESG, as the consideration really develops. And so you'll see here on the slide that we did align with multiple standards. So I hope that you take a moment to read it when it comes out. You know, you'll see in there both a picture of things we've done today, but also how Maxion thinks about the future and what we're looking to accomplish tomorrow. And I invite you to stay with us on our journey as we build our company. And thank you for your time.
Well, thank you very much, Lindsey. Thank you for that message, and also for taking us through the sustainability program. We do have some questions coming through, as always, so I'll fire them to you now. How transparent is Maxion regarding its ingredients, in inverted commas? So in terms of raw material supply chain, how much information can you share? Things like polysilicon.
Sure. So what? That's obviously a very hot topic these days, as we all know. Well, what we do, there's two different panels that Maxion sells, right? We've got our IBC panels, which we have, you know, we use European and American suppliers of polysilicon. And then we also sell P-series through one we're going to recently announced. We'll be doing that in-house and for the US market. And then we also do it through a joint venture in China. And what we have in place already, actually, through you know, we bid into certain carbon, low carbon programs, such as the tariffs in France. So we have a way of tracing back to polysilicon, and we do it through the MES program. So it's a barcode, and we're going to roll that out additionally to all of the PV that we sell. So we are implementing traceability, and it's going to be in compliance with the SIA protocols on traceability as well.
Okay, thank you very much for that, Lindsey. Well, we have come to time. Lindsey Wiedmann, Chief Legal Officer with Maxion Solar Technologies. Thank you very much for joining us today.
Thank you.
Thank you. And we've come to the end of our session. A bit delayed, but in the last 2 hours, we've seen the importance of focusing on small details, but also keeping in mind the holistic approach. We discussed how large and format and high-powered modules pose a number of quality risks: low light performance, cell cracking, faulty soldering, mischaracterization. However, they can be managed. That quality programs and automation in power electronics production are becoming more sophisticated in new fabs. And as you can see on the next slide, we also discussed small details in installation protocols can cause big O&M problems, even on small plants. Uncommon equipment risks must be managed. Notions of quality are being extended to aspects of ESG. And overall, the European solar market is poised to embark on an unparalleled period of opportunity, and technology is changing fast. For solar's promise to be fulfilled, quality is paramount.
Thanks again also to our Platinum and networking partners, and for the partners that took part in this session: STS, Longi Solar, Coolback Company, Shoals Technologies, Growatt, Stäubli Electrical Connectors, and Maxion Solar Technologies. And there are lots more details regarding what was discussed over the last 2 hours in the latest edition of PV Magazine Global. And here we'll provide you with a promo code to kind of reward your participation. And I do encourage you to pick up the latest copy of the magazine, PV Magazine Global.
Yes, and during the upcoming 2-hour lunch break, you'll have plenty of entertainment. You can meet most of the speakers from this session in the Meet the Speakers room and continue the conversation there. Also, our colleagues Mark Hutchins and Rachel Sorensen look forward to chatting with you in the English networking room. And as you can see behind me, this is our new magazine, just released. And if you speak Spanish, head over to the Spanish room. PV Magazine Spain editors Pilar Sanchez Molina and Emiliano Bellini have invited Antonio Delgado Rigal, founder and CEO of Aleosoft, to talk about the Spanish market, electricity prices, the future of PPAs, and more. If French is more your beat, our PV Magazine France editors Quenelle Debout and Joël Spaes will continue the conversation of changing module sizes with Julien Jourol, Director of Operations of BayWave France, in our French networking room. If you do prefer to chat one-on-one, either send messages to a fellow attendee to set up a meeting or join the speed networking right now. Create new connections and maybe start unexpected collaborations. For even more brain stimuli, check out our Play to Win scavenger hunt and solve the challenges to learn some interesting facts about solar. Even more facts, I have to say. And maybe you'll manage to beat out your fellow attendees and win one of the prizes. Actually, the top 3 all have a chance to win a PV Magazine subscription.
Exactly, so don't hesitate to do that. And also, you go into the running to pick up some great prizes if you fill out one of our surveys. After each session, we'll be asking for your feedback. It's really important for us to optimize our events and to keep improving what we're doing here. Below the live stream or in the menu on the left, you can see a link to this session's survey. Let us know what you took away from the last 2 hours. And coming up on the live stream this afternoon, asset management, due diligence, financial, contractual, and technical perspectives of an evolving industry with speakers from DuPont, PI Berlin, Jinko, and many more. Make sure you stick around for that. The live stream continues at 2 p.m. Berlin time.
Exactly. So thank you all for joining and getting involved in this Quality Cornerstone session. For now, from Jonathan Gifford and Friederike Egerer, goodbye.